In this video, we will discuss the concept of inverse Laplace transforms. So, we already know the concept of the Laplace transform. So, inverse Laplace transforms, as the name implies, is only the reverse process. So, kung sa Laplace transform, meron tayong given a function of t, and then we will use Laplace transformation to get a function of s. Pag ganamit natin yung inverse Laplace transform, we are given a function of s, and then we want to find the function of t na may ganun Laplace transform. Okay? So, para yung relationship ng integral at ng derivative, and so on. So, vice versa. Okay, so the inverse Laplace transform is denoted by this symbol here. So you have the -1 no, dun sa symbol ng Laplace transform, just to denote that what you're getting is the inverse Laplace transformation. So the inverse Laplace transform of capital F of S is equal to f of t. And we have four methods on how to get the inverse Laplace transform of a given function. One is by formula, the other is by completing the square, you have by partial fractions, and by convolution theorem. So in this video, we will have examples using the first three, and then later on we'll have the fourth one. Now take note that the inverse Laplace transform also follows the linearity property just like the Laplace transform. And so if a and b are constants and f of s and g of s are continuous functions, then the inverse Laplace transform of a f of s plus or minus b g of s is equal to a inverse Laplace of f of s plus or minus b inverse Laplace of g of s. So by formula, ay straightforward lang yung ating approach, no? Kapag alam natin yung Laplace transform ng isang function, alam na rin natin kung ano ang itsura ng magiging inverse Laplace ng function of s kasi ibabaliktad lang natin. For instance, the Laplace transform of k is k over s, so we know that, which implies that the inverse Laplace transform of k over s should be k. So baliktaran lang. Also, the Laplace transform of e to the kt is 1 over s minus k, which now follows that the inverse Laplace of 1 over s minus k is equal to e to the kt. The Laplace transform of t to the n is n factorial over s to the n plus 1. So it follows that the inverse Laplace of n factorial over s to the n plus 1 is equal to t raised to n. Also, Laplace transform of cosine kt is s over s squared plus k squared. So the inverse Laplace of s over s squared plus k squared is cosine kt. The Laplace transform of sine kt is k over s squared plus k squared. So it follows that the inverse Laplace of k over s squared plus k squared is sine kt. We know that the Laplace transform of cos kt is s over s squared minus k squared. So the inverse Laplace of s over s squared minus k squared is cos kt. And the Laplace transform of sinh kt is k over s squared minus k squared. And so the inverse Laplace of k over s squared minus k squared is sinh kt. So the idea is, kailangan, again, yung form ng yung f of s should be one of these forms. Kapag hindi pa siya totally ganyan yung pattern or yung form niya, then hindi pa natin siya agad-agad pwedeng masabi na yung inverse Laplace is equivalent to this. Okay, but as long as we can see to it that the form follows strictly one of this, then we can use straightforward itong mga formula na to. Okay, so if hindi naman siya straightforward na naka-transform na sa pattern na ganyan, then we have to do algebraic methods on how to simplify your expression. So let's say, for example, you want to evaluate the inverse Laplace of 2s cubed plus s squared minus 1 all over s raised to 5. Let's make it raised to 5. So in this case, meron tayong form na hindi naman siya agad-agad na makukuha ng inverse Laplace transform kasi isang complex pa siya na function. No? So what we do is we simplify this by dividing all terms by s to the fifth, or by reducing it into or separating it into similar fractions. So you have inverse Laplace of 2s cubed over s to the fifth plus s squared over s to the fifth minus 1 over s to the fifth. Now simplifying further, you'll have the inverse Laplace of 2 over s squared plus 1 over s cubed minus 1 over s to the fifth. So if we will look into this, okay, So we have here three parts, no, or three terms. Okay, so we can look at it one by one. Okay, just to make our explanation clearer. So you have here inverse Laplace of 2 over s squared. We can rewrite this as 2 inverse Laplace of 1 over s squared based on the linearity property. Now, ang ibibigay sa atin na form na to is ang pinaka malapit will be the t to the n. Okay? Because you have t to the n inverse Laplace ng n factorial over s to the n plus 1. So, yan ang pinaka posible kasi you have 1 over s squared. But, it doesn't follow strictly yung form na n factorial over s to the n plus 1. So, kapag nirewrite natin yung exponent o denominator, you actually have here 2 inverse Laplace of, so 1 over s to the 1 plus 1, okay? Now, in this case, no, since ang kailangan lang naman natin, ang n natin dito is 1, right? Okay, kasi n plus 1 sa denominator, eh. Kailangan lang natin dito is 1 factorial, so 1 naman na yun. Okay, so this one is straightforward, okay, 2t. Okay? Kasi andyan na yung form. This is n factorial over s to the n plus 1. So that's 1 factorial over s to the 1 plus 1 where n is equal to 1. So that's t to the n. So basically, you have t to the 1 or you have here 2t. For the second term, you have the inverse Laplace of 1 over s cubed. Now again, this should follow the inverse Laplace that will yield t to the n, but sa denominator, you actually have 1 over s to the 2 plus 1. And so, your n is 2, pero sa numerator, you only have 1 as a constant. Para mag-follow na ang ilalabas natin dito na inverse Laplace is t squared, no, kasi nga yung n natin is 2. Okay, kailangan dun sa numerator, you will have here 2 factorial. But when you multiply this by 2 factorial, kailangan sa labas, okay, we neutralize this by 1 over 2 factorial. Therefore, okay, you have here inverse Laplace of 2 factorial over s to the 2 plus 1. That will yield you t squared. But because you multiply 2 factorial inside para magsunod siya dun sa pattern, you have to multiply also outside by 1 over 2 factorial or that will be 1 over 2. Now, for the third term, you have here the inverse Laplace of 1 over s to the fifth. Just like yung ating 1 over s cubed, same thing, it will yield t to the n. Now, this one can be written as inverse Laplace of 1 over s to the 4 plus 1. But then again, para mag-yield to ng t to the n, which is t to the fourth, kailangan yung nasa numerator niya should be n factorial, which is 4 factorial. So if I multiply 4 factorial here, I should multiply 1 over 4 factorial sa labas. And so this will yield t to the fourth. And then you have 1 over 4 factorial is 4 times 3 times 2, 1 over 24. Therefore, our final answer will be, the inverse Laplace of this will be 2t plus 1/2 t squared minus 1 over 24 t to the fourth. Next, let's try having inverse Laplace of 4s minus 5 over s squared plus 16. So again, yung form natin, it's not among those na mababaliktad agad natin siya yung inverse Laplace transform, but since the numerator is a binomial, we can rewrite this as the inverse Laplace of 4s over s squared plus 16 minus inverse Laplace of 5 over s squared plus 16. Now, obviously, this one will yield either cosine or sine, no, kt, because of the denominator, it's s squared plus 16, s squared plus 16. Now, by linearity property, I can rewrite this as 4 inverse Laplace of s over s squared plus 4 squared minus 5 inverse Laplace of 1 over s squared plus 4 squared. Now, para ito ay mag-yield ng, kasi s yung nasa taas, no? Mag-yield ng cosine, we will have to have s over s squared plus 4 squared where k is 4. So, this one is okay. This one will yield cosine kt. For the second term, ang problema natin dito, since yung nasa numerator mo is only a constant, this will yield sine kt, but the constant should be this one, k, which is 4, and not 1 or not 5, no? Kaya nilabas natin yung 5. And so, para makompleto natin yung form para sa yielding sine kt, we have to multiply the numerator by k, which is 4, and so you have to multiply outside by 1 over 4. That's why you'll have here 5 over 4. Therefore, the inverse Laplace transform of this given function will just be 4 cosine 40 minus 5 over 4 sine 40. Now, our previous two examples, we just do basic algebraic techniques on how to separate our given function in such a way that term by term, we can immediately get the inverse Laplace transform by formula. Now, in some cases, like for example, the inverse Laplace of s minus 2 s minus 2 all over s squared plus 2s minus 3. Ito, walang-wala doon sa form ng inverse Laplace yielding yung formula natin ng inverse Laplace transforms. Kasi unang-una, you have a denominator here that is composed of 3 terms. No? So, doon sa yielding cosine, cos, sine, and sinh, you only have sum or difference of 2 squares. But this one, you have a trinomial. Now, what we can do here is we can use what you call completing the square. So, pupunta na tayo ngayon sa second technique. Kapag meron tayong ganyang forms, denominator, we can use completing the square. Bakit? Kasi completing the square basically gives us perfect square trinomial plus or minus a constant. Okay? Which you can rewrite or you can see it as difference or sum of 2 squares later on. Alright, so, if you may recall, when you complete the square of a given function, so yung denominator, no, s squared plus 2s minus 4. So when you complete the square of a given not function, a given expression, okay, s squared plus 2s minus 3, what you do is you divide the middle coefficient, numerical coefficient by 2. Okay, so in this case, you have 2 over 2, you have 1. Add the square of that, okay, add the square of that to your expression. So s squared plus 2s plus 1 squared, and then you have here the minus 3. If you add, then you have to subtract the same thing. So minus 1 squared. But of course, you will not cancel later on. No? So you have here s squared plus 2s plus 1 is now a perfect square trinomial which can be written as s plus 1 quantity squared. And then you have here minus 3 minus 1, so you have minus 4. And so, this expression here, okay, the f of s inside the inverse Laplace transform can be written as s minus 2 all over s plus 1 squared minus 4, which is inverse Laplace of s minus 2 over s plus 1 squared minus 2 squared. And so, parang meron ka ngayon na binomial na lang sa denominator. No, yun nga lang, instead na s, meron kang s plus 1. So, what does that imply? Kung s plus 1 squared yan instead of s squared, meaning, shifted yung ating function. No? So, yung f of s natin is nakuha natin using the shifting theorem. And so, you have to find a way on how to make this work. Kung s plus 1 ito, dapat yung nasa numerator mo is also s plus 1. But you have here s minus 2. So, paano yun magiging s plus 1 yan? So, we can modify the numerator. Okay? So, you have here inverse Laplace of, we can rewrite this as s minus 1, or s minus 2 rather, Para maging plus 1, I have to add 3. Para s minus 2 plus 3 is s plus 1. But since I add 3, I should subtract 3 also. Para I just added 0. Divided by s plus 1 squared minus 2 squared. So basically, what we have here is inverse Laplace of s plus 1. So itong part na to, that's s plus 1 minus 3 all over s plus 1 squared minus 2 squared. So pwede nga ngayon nating paghiwalayin yan into two terms. So you have the inverse Laplace of s plus 1 over s plus 1 squared minus 2 squared minus the inverse Laplace of 3 over s plus 1 squared minus 2 squared. So yung first term natin is readily yielding cosh kt kasi may s sa taas Pero dahil s plus 1 yung nandiyan sa taas, ibig sabihin shifted siya at a equal to negative 1. And so this is equal to cosh 2t. So your k is 2. But since shifted to, you have e to the negative t. Multiply to it. Your a is negative 1. Para dun sa second term, we can bring this out actually, no? Kasi ang ating k dito is 2. So kailangan yung nasa taas is 2 also. But you have here 3. So what I do is I multiply here 2. C3 pwede nating ilabas na lang. We can bring this out dito and then multiply 2 inside and then multiply 1/2 outside. Such that this thing here, 2 over s plus 1 squared minus 2 squared will yield sine kt. So you have here minus 3 over 2 sine 2t. But since you have here s plus 1, shifted to at a equals negative 1, so you have multiplier that e to the negative t. So this is your inverse Laplace transform. Okay, so let's have another one using completing the square. So let's have the inverse Laplace of 4s minus 3 all over s squared minus 4s plus 13. So with this, you complete the square first of the denominator. So you have here s squared minus 4s plus 13. So you have s squared minus 4s. Divide the middle numerical coefficient by 2. So you have negative 2. Add the square of that. So plus negative 2 squared. You have here plus 13 minus negative 2 squared. So you have here s minus 2 squared plus 13 minus 4. So you have plus 9. So we can rewrite this as inverse Laplace of 4s minus 3 over s minus 2 squared plus 3 squared or plus 9. Now, just like what we did in example number 3, dahil ito ay s minus 2 squared, hindi lang siya basta s squared. So you have s minus 2 squared. It means that shifted yung ating given na sagot, or yung function natin na given ay basically comes from shifting theorem. So you have here 4s minus 3 over s minus 2 squared plus 3 squared. Ang pwede natin gawin, yung nasa numerator, kailangan natin pilitin na maging s minus 2 or makapaglabas tayo ng s minus 2. Now, because meron tayong 4 na nakamultiply doon, we have to first factor out the 4. We have to first factor out the 4. And how do we do that? By factoring, we will have here 4 times s. But this one will yield 3/4. Kasi if factor mo rin yung 4 dun sa 3 So magkakaroon ka ng 3/4. So nasaan yung s minus 2 natin? So what we do is this. Pag finactor out mo yung 4 sa s, kailangan yung matitira dito, yung constant dito, Pag finactor out mo yung 4 dun sa s, kailangan ang matitira dun sa constant mo is 2. Paano magtitira yung 2 dito kung ang i-factor mo ay 4? Kailangan ang meron ka ay 8. So, para magkaroon ka ng minus 8 dyan, you have to have 4s minus 3 minus 5. And since nag-minus 5 ka, dapat magpa-plus 5 ka rin. Okay, so over s minus 2 squared plus 3 squared. And so for this, you'll have inverse Laplace of 4s minus 8 plus 5 all over s minus 2 squared plus 3 squared, which will yield inverse Laplace of, we can rewrite this as 4s minus 8 over s minus 2 squared plus 3 squared plus inverse Laplace of, yung 5 ilabas natin, and then you have 1 over s minus 2 squared plus 3 squared. And then if you factor out here the 4, you'll have the inverse Laplace of 4 times s minus 2 all over s minus 2 squared plus 3 squared. Plus 5 inverse Laplace of 1 over s minus 2 plus 3 squared. Now, this first term here simply yields cosine kt, okay? Cosine 3t. Your k is 3. Now, you have here your 4, so that's a constant. Okay? Pwede mo ilabas yan doon. Now, since this one is s minus 2, this is shifted with a equal to 2. So, this is e to the e to the 2t. So, e to the 2t plus, for this one, I have here 5 outside, but my k is 3. Para mag-yield to ng sine kt, kailangan meron din 3 na multiply dito. So, times 3, and then times 1/3. So, that's over 3. Okay, and so, this one you'll have 5 over 3 sine 3t. But since this is s minus 2, again, it's shifted at a equals positive 2. So, you have e to the 2t also. So, this is your inverse Laplace transform. Alright, for our last example, okay, we solved the same problem, okay, the third problem that we did. Inverse Laplace of s minus 2 over s squared plus 2s minus 3. But this time, instead of using completing the square, let us use partial fractions. Okay, a partial fraction is ginagamit natin for us to be able to separate your given fraction into several smaller fractions. Okay, now, we have 4 cases. For this example, it's case 1 because when you factor the denominator, you'll get 2 linear factors, unique factors. So, let's rewrite this s minus 2 all over, factor the s squared plus 2s minus 3, so you have s plus 3, s minus 1. Now, to set up the partial fraction of this, it's simply a over s plus 3 plus b over s plus s minus 1. Minus 1. So, you can imagine, as long as masolve natin si a and b, the inverse Laplace transform of this is madali na lang kuhanin kasi this will just be simply a constant over s plus 3 plus a constant over s minus 1, simply yielding e to the kt later on. So, solving for a and b, multiply both sides by this denominator, you will have s minus 2 is equal to a times s minus 1 plus b times s plus 3. Now, the easiest approach to this, to solving for a and b, is by substitution. Okay? We let s be equal to 1. If s is equal to 1, then you have 1 minus 2 is equal to a times 1 minus 1 plus b times 1 plus 3. So, ginawa natin yun kasi when s is equal to 1, yung nakamultiply sa kanya na a, automatically mawawala dun sa equation kasi magzi-zero yung product. So, you'll have here negative 1 is equal to b times 4, or you have b equals negative 1 over 4. Now, setting now s be equal to negative 3, you'll have here negative 3 minus 2 is equal to a times negative 3 minus 1 plus b times negative 3 plus 3. Si b naman ngayon yung magzi-0, so you'll be able to solve for a. So negative 5 is equal to a times negative 4, or you have a is equal to positive 5 over 4. So knowing a and b, we can now rewrite our given expression. Therefore, the inverse Laplace transform of s minus 2 over s squared plus 2s minus 3 is equal to the inverse Laplace of, you now use this. So you have 5 over 4 over s plus 3 plus negative 1 over 4 over s minus 1, which is the same as the original given kasi nga partial fraction lang natin siya, which we can rewrite as 5 over 4 inverse Laplace of 1 over s plus 3 minus 1 over 4 inverse Laplace of 1 over s minus 1, which simply yields 5 over 4 e to the negative 3t minus 1 over 4 e to the t. Kasi ang form natin is 1 over s minus k. So, ang magiging inverse Laplace is e to the kt.